everyone in this video, and what we have today is four particles of equal masses m moves along a circle of radius r under the action of their mutual gravitational attraction. Find the speed of each of these particles. So we will consider one particle as reference and try to explain this entire problem. So let this pair be the particle, or this particle be the one of our interest. So these four eventually at the beginning of time are under equilibrium. Now when a slight disturbance is applied to any one of them, the mutual attraction drives them, which causes the rotation. So the radius of this circle along which they are rotating is r, the mass of this particle are m, and so what we are asked to find is the velocity, the linear velocity of each of these, which I assume to be v. So the centripetal force acting on this particle, I name this particle as A, let the centripetal force, the centripetal force is equal to m v square by r, where m is the mass of this particle. Now the forces acting on this particle are, first the force of attraction due to this particle right here, then the force of attraction due to this particle right here, and then the force of attraction due to this particle right here. I name these forces as F1, F2, and this one will also be F1 because these two particles are of same mass, and the position of these two particles relative to these are same, so the forces will be same. So F1 is equal to gm m, which is gm square, by the distance between the particles whole square. So this distance can be easily found out by Pythagoras theorem. It will be equal to root 2 r. I can show this. This is r, this is r. So by Pythagoras theorem, this is r square plus r square, which is root 2 times r. So this will be gm square by 2r square. So now this force is acting at this direction, but what I need is the y component of this force. The y component of this force will be Fy is equal to F1 times cosine 45 degree, because this angle is 45 degree. So F1 is gm whole square by 2r square, and cos 45 degree is 1 by root 2. So this entire thing is equal to gm square by 2 root 2 r square. I will take this as 1. So the reason why I am taking the y component is because the y component is responsible for this centripetal force, not the x component. So I have got F1, this is also equal to F2, because this is also equal to the force due to this particle. I have named this as F1 already, so I won't have to write this again. Now what we will do is try to find this F2 force. So F2 is equal to gmm by r square. Here the distance will be 2r, so 2r whole square, so it ends up being gm square by 4r square. So Now I will name this as 2. So the equation becomes m v square by r is equal to gm square by 4r square plus gm square by 2 root 2 times r square plus gm square by 2 root 2 r square. So after solving this entire part, what I get is I multiply gm square by 4 r square plus gm square by root 2 times r square. I would need a little bit of extra space, so m v square by r is equal to this. I have to do a little bit of simplification. Gm square by r square 1 by 4 plus 1 by root 2, which is equal to gm square by r square. So I will multiply a 4 over here, and I will multiply a root 2 over here and a root 2 over here, and also will multiply a 2 and a 2. So what I get is 1 plus 2 root 2 by 4. So this ends up being v is equal to, I will strike off this r, I will strike off an m. So gm by r 1 plus 2 root 2 by 4. This is the velocity of the particle